Hi, my dear learners. Welcome to our third lesson in science. We are still under energy, and the unit is conversion and conservation of energy. Today, we are looking at how to calculate kinetic energy of a body. Calculate kinetic energy of a body. Now, by way of revision, in our previous lesson, we looked at the factors on which potential energy of a body depends on, which are mass of a body, height of a body, acceleration due to gravity. Then we proceeded to look at mathematical representation of potential energy. So the formula is mass times acceleration due to gravity times height. Today, we would like to study mathematical expression for calculating kinetic energy of a body. Now, just as we looked at factors on which potential energy of a body depends on, we will as well look at factors on which kinetic energy depend on. And here we are looking at two of them. One, mass of the body, still measured in kilograms. Then velocity or speed of the body, measured in meter per second. So take note of these two factors. Mathematically, kinetic energy is equal to 1/2, that is half of the mass times velocity times velocity. In short, kinetic energy is equal to half mv squared. So take note of these formulas. We shall soon use them to calculate some word problems. So let's take our first problem of the day. A bullet of mass 20 grams fired from a gun traveled at a speed of 10,000 meters per second and hit a tree. Calculate the kinetic energy the body possessed before hitting the tree. Calculate the kinetic energy the bullets possessed before hitting the tree. So as usual, we shall write the data. Mass of bullet is equal to 20 grams, which must be converted to kilograms by dividing 20 grams by 1,000 grams, or in kilograms. So the results will be 0.020 kilograms. The velocity of the bullet from the problem is given as 10,000 meters per second. So now let's look at the calculation. So we code the formula: half times mass times velocity, or half times mass times speed times speed. You will be wondering the difference between the velocity and speed. They are not really different, but for direction. What I mean is, speed is the ratio of distance to time, whereas velocity is not only the ratio of distance to time, but the direction in which the body is moving. So that's how velocity is differentiated from speed. Now let's move on. So by substitution, we have half times 0.020 kilograms times 10,000 meters per second times another 10,000 meters per second. I hope you understand why we are repeating the values. Yes, because in the formula, velocity has been repeated. So now let's look at further simplification. So the only thing that has changed here is the decimal fraction 0.020 kilograms being changed into a fraction, common fraction 20 out of 1,000 kilograms. So now we'll do the simplification, and the simplification results in 2 billion divided by 2,000, all measured in joules. So we cancel out the zeros, and the 2 divides the 2 up there, and we're left with 1 million joules, or 1,000 kilojoules. Now, do not be confused at this point. Remember, just as we have 1,000 grams giving 1 kilograms, we also have 1,000 joules giving 1 kilojoule. I repeat, just as we have 1,000 grams is equal to 1 kilogram, we also have 1,000 joules being equal to 1 kilojoules. That is why the first answer, 1 million joules, was changed to 1,000 kilojoules, just to make the number smaller in sight, but not in value. The value is still the same, but it has occupied smaller space. All right, now try this problem. A bird of mass 0.3 kilograms is flying at a velocity of 20 meters per second. Calculate the energy it possesses while flying. Of course, you know the energy we are calculating while flying. Remember, it is in motion. Now, the mass at this time remains in its standard units, kilograms, so there's no need to change 0.3 to any other unit. So maintain the value. Try it and see if you get 60 joules. All right, by way of summary, we looked at the two factors kinetic energy depends on, which are mass of the body and velocity of the body. We proceeded to look at the formula used to represent kinetic energy as half times mass times velocity times velocity. In short, half mv squared. Advanced learning. Try as much as possible and read on energy transformations based on the law of conservation of energy you learned in class 5. Remember to download the exercise and do it properly. You can also download the PDF notes of this lesson. Till we meet again. Bye.